Oh, hey. Today I thought we might talk about endothermic and exothermic reactions, or what's hot, what's not. All right, so endothermic and exothermic reactions, it's really all about the flow of energy. And in this case, I'm going to refer to energy as E. Energy is either flowing into the system or it's going to flow out of the system. All right, so a bit of a squirrel moment here. So this is a small diversion for some helpful background information. Think of thermal energy or thermal heat as energy. Okay, so the more energy you have, the more heat you have. The less energy you have, the less heat you have. So some units of heat, of energy. The joule, which measures the amount of energy. It's about the energy needed to raise an apple up to a height of 1 meter. I realize it's a little bit obtuse. A calorie, yes, like you see on the side of the cereal boxes, etc. This is found in food, and it is the quantity of heat that's required to raise the temperature of 1 gram of water by 1 degree Celsius. So again, for example, if you want to raise the temperature of 10 grams of water from 20C to 22C, you would need 20 calories of heat to do that. So a calorie is something that is burned as fuel to produce heat, to produce energy. All right, last is law of conservation of energy. So this states that no matter is ever created or destroyed, it just changes state and kind of moves around. So in this case, it moves from a system where the reaction takes place to the surroundings where it's everything outside the system. So getting back to my glass of water here, or my glass of ice, maybe soon to be water, this is the system. Okay, so the ice is the system. Everything around the ice is the surroundings. Okay, so this is the system, that's the surroundings. So endothermic. So this is when energy flows in to the system. So the energy must be added for the reaction to occur. Builds bonds. So endo is inside and therm is heat, like thermometer. So the temperature of the surroundings decreases. So getting back to my example here, the ice, the reason that it feels cold is because it's drawing energy into the system from the surroundings. And remember, when you have less energy, you have less heat. So less energy, less heat, which is why this feels cold, because the energy is flowing from surroundings into system. So and so like a cold pack. So basically a cold pack is when the cold ammonium nitrate interacts with the water and draws energy away from its surroundings, which makes it cold. So you've got a cold pack for your knee or whatever you hurt. And again, that's going to be melting ice as well. So it's drawing energy in, right? So the energy is going in to melt it. But in the meantime, since it's drawing energy away from the system, it feels cold. All right, so another way of seeing it. So with an endothermic reaction, you've got energy going into the system, which means the temperature of the surroundings is going to drop. All right, let's talk exothermic. So exothermic is when energy flows out of the system. So out of the system into the surroundings. So the reaction occurs spontaneously. So this is when bonds are broken. So exo is outside, therm is heat. So this is when the temperature of the surroundings increases. Because remember, it's going from system to surroundings, and as the energy leaves, the heat goes up. More heat, more energy. More energy, more heat. Less energy, less heat. So here we've got, this is definitely not, although actually, you know what, this could be exothermic as well. Ice is amazing. Gotta love a little frozen H2O. Exothermic is like any combustion, like lighting a candle. So basically, a candle has hydrocarbons in it, and when the hydrocarbons react with the oxygen, it breaks the bonds, and whenever you break bonds, you release energy. So that's why a candle feels hot, is because the energy is being released from the system into the surroundings. All right, so here we go. So this is an example of an exothermic reaction. So the energy is leaving the system, which means that the temperature of the surroundings are going to go up. Because remember, the energy, more heat. So, yeah, that's endothermic and exothermic reactions. It's, it's a pretty hot topic, but not always. All right.